Hello everyone. The topic of today's presentation is Isaac Newton and his mathematical contribution. So, as from its topic name itself, it will be very much clear to you all that this video is going to be more specifically focused on Isaac Newton's mathematical contribution and how his contribution in the field of mathematics changed the whole course of science. So, Isaac Newton. What is the first thing that comes in our mind when we listen name Newton? I think from most of you, the answer will be gravity or Newton's laws of motion. And a picture flashes in our mind that Newton sitting under the apple tree, suddenly an apple falls, struck his head, and he got the thunder in his mind, and we get the universal law of gravity. Okay, honestly speaking, how many of us knows him because his great contribution in mathematics? I think there will be very few one who will say that yes, the first time when I came to know about Newton, it was just because of his mathematical contribution. There will be very few one. So let's start the presentation. Here we'll try to get more familiar with his mathematical contribution and how it changed the whole course of science and the world. So this is a table of content. These are the topics we are going to deal with in this presentation. And through this, we'll try to get more familiar with his mathematical contribution. So firstly, we'll talk about early life and career, then talk about his education, and then later we'll talk about some of his scientific achievement and discoveries. And after that, we'll see some of his mathematical contribution. And lastly, we'll talk about how Isaac Newton changed the course, changed the world with the invention of calculus. So let's start the presentation. Early life and career. Isaac Newton was born on Christmas Day, 25th December 1642, in the country of Lincolnshire, England, according to the Julian calendar used in England at that time. His father's name was also Isaac Newton, who died just before his birth. When Newton was just 3 years old, his mother remarried and went to live with her new husband. And because of that, Newton had to live with his maternal grandmother. From the age of about 12 until he was 17, Newton was educated at the King's School, Grantham, where he was taught the classics but no science and mathematics. When he was just 17, his mother stopped his schooling so that he could become a farmer. But fortunately for the future of science, Newton found that he had neither aptitude nor liking for farming. So lastly, his mother allowed him to return to school, where he finished as a top student. You can see the picture of King's College, Grantham here. Now let's move and talk about his education. In June 1661, he was admitted to Trinity College, Cambridge. At that time, the college teaching were based on those of Aristotle, incorrect ideas from ancient Greek times. And this was despite the fact that 25 years earlier, in 1638, Galileo Galilei had established a new scientific basis for physics of motion with his masterpiece, Two New Sciences. Later, Newton began to disregard the material taught at his college and started preferring to study the recent and the more scientifically correct work of Galileo, Boyle, Descartes, and Kepler. In 1665, he discovered the Generalized binomial theorem and began to develop a mathematical theory that became calculus. In 1665, because of plague, his university got closed and he had to return to his home. And this 2 years has been proved the golden time for the Newton, because the most of discoveries that he made, discovered theories of calculus, optics, and law of gravitation, all this theory was given by Newton in this 2 years period.
Okay, so now let's talk about some of his scientific achievement and discoveries. Newton was the one who generalized the binomial theorem, showed that the sunlight is made of all the colors of the rainbow, built the world's first working reflecting telescope. He was the one who wrote Principia, one of the most important scientific book ever written. In it, he used mathematics to explain gravity and motion. He was the one who discovered the law of universal gravitation, proving that the force holding the moon in orbit around the earth is same force that causes an apple to fall from a tree. Formulated his three laws of motion, Newton's law, which lie at the heart of science of moment, showed that the Kepler's law of planetary motion are a special case of Newton's universal gravitation, proved that all objects moving through space under the influence of gravity must follow a path shaped in from one of the conic sections such as a circle, a ellipse, or a parabola, showed that the tides are caused by gravitational interaction between the earth, the moon, and the sun, discovered calculus. So these are the some of these mathematical contribution: Newton's fundamental theorem of calculus, generalized binomial theorem, Newton's method, Newton's identity, cubic plane curve, Newton's polynomial, Newton's forward difference formula, calculating slope of curve, infinite series. So let's talk about it. Newton's fundamental theorem of calculus. The fundamental theorem of calculus establishes a relationship between the concept of differentiation and integration. According to theorem, these two concepts are inverse of each other. Generalized binomial theorem. Newton is credited for providing a generalized expression of binomial theorem. You can see the binomial expansion in Newton's original notation here. And these are the binomial expansion up to fourth level, visualization of binomial expansion up to fourth level. Now let's move. Newton's method. Newton's method was found by Isaac Newton and Joseph Raphon. So is also known as the Newton's Raphon's method. This method can help you to calculate a better approximation of roots of a real valued function. Newton's identity. Newton's identities were found by Newton in 1666. With the help of Newton's identities, one can find the power sum of roots of the polynomial without actually finding the roots. So lastly, we'll talk about how Isaac Newton changed the world with the invention of calculus. So firstly, we'll try to know about what is calculus. Calculus is the quantitative understanding of how things change, not only velocity but in physics, in chemistry. This mathematical framework become the language in which modern science is formulated. Calculus has uses in physics, chemistry, biology, economics, pure mathematics, and all branches of engineering and more. I think it will be not an overstatement to say that Newton's insight in the development of calculus has truly revolutionized our ability to pursue a new branches of science and engineering. It used in problem when a quantity changes as a function of time, which is how most problem behaves in reality. When he invented the calculus and outlined its uses, Newton's made one of the most important breakthroughs in the mathematical history, and it is still vital to this day. Without calculus, we wouldn't have radio, television, microwave. We wouldn't have been able to reach moon and Mars. We wouldn't have nuclear energy and nuclear weapons, GPS for lost travelers,